Okay, so in this case, we're graphing each linear equation. Now remember, when you graph an equation, and we had the discussion last class period, when you graph an equation, you're graphing the solutions. You're finding the solutions. And you notice that when we graph these linear equations, how many solutions were there? An infinite number. That's why we drew the line. That's why we drew the line, because there were an infinite number of solutions. There's no way you could list them all. Just like in the previous problem where we most of the times we had just one solution, so you could list it. You could tell me x equal 5. Here, and notice that in the work you just turned in, each of those equations had how many variables? Just one. They were variable x, a variable t, whatever it may be, but there's just one variable. The linear equations, how many distinct variables did you see? 2. X and what? Y. Okay? So you ended up having an infinite number of solutions. So you had to graph them. Okay? Some of you though are still having issues with multiplying fractions, you're having issues with signed numbers. I suggest you use your calculator and don't do this in your head, because you're going to be getting wrong answers. Use your calculator. All right. Yeah, you can use your calculator in your test. All right, let's look at this one. Y equals negative 4 fits x plus 2. Now, the easy kind is whenever the variable y is by itself. That's the easy kind. And so this is an easy kind. Y is by itself. Now, the way you want to do this on the worksheet, the one I gave you last class period, was to do this using a t-table. No other way. Using a t-table. And so when you use a t-table, so I got to see that t-table. So make sure Thursday when you turn in that worksheet I gave you last class period, you show me the t-table. Is that understood? Okay, because I told you to do that. Use a t-table. All right. So, what was one of the numbers, though, I always asked you to use? 0. 0. Now, some of you are doing this in your head, and no fault in your own, you're having difficulty doing in your head. So I suggest you write it out. So, if x is 0, I say y equals negative 4 fifths times what? 0 plus 2. Now, at this point in your life, you should know that any number times 0 is 0. And what's 0 plus 2? 2. So I have the point 0, 2. So that's one of my solutions. So that means if I plug in 0 for x and 2 for y, the left side equals the right side. Now we also saw that if the coefficient of x, and what's the coefficient of x here? No, what's the coefficient of x here? Negative 4 fifths. Okay, coefficient of x, negative 4 fifths. So we saw that if the coefficient of x is a fraction, there are certain numbers for x we prefer to use. Now you could let x be fractions, you can let x be decimals, you can let x be any value you want. But it'll make things a lot easier for you if you choose an x that is divisible by what number here? 5, the denominator. Okay. So give me some numbers that are divisible by 5 besides 0. 5, what's another one? Okay, let's do 5, say negative 5. Then say what? 10, then say what? Negative 10, and so on. So I do want you to start using some negative numbers, because on my math lab, some of those values are going to be given for you. Some will be negative, and you have to learn how to deal with negative values. All right, so let's go to 5 now. So if x is 5, I say y equals negative 4 fifths times 5 plus 2, right? Then what's happening is that some of you, and you had this in previous courses and you're still struggling with this, some of you, not all of you, but you're struggling with multiplying fractions. So I have a negative 4 fifths times 5. Some of you still seem to think that you say 5 times 5 is 25. You don't. You got to remember that this 5 is the same thing as saying 5 divided by 1. And then you reduce first. Remember the whole point of multiplying by a number divisible by 5 is to make this number down here what kind of number? 1. 5 into 5 is 1. 5 into 5 is 1. So this fraction right here, now y'all agree that this is two fractions you're multiplying, right? So this fraction right here is now what number? Negative 4. This fraction right here is what number? 1. What's negative 4 times 1? Negative 4. Once you find, now all I found, so at this point was this right here, right? So draw this if you have to. And some of you are not doing what I'm asking you to do, and you're still struggling with this. Put something like this under it, and then you realize, hey, what I just found was what number? Negative 4. Then I got to say plus 2. Use your calculator if you don't remember how to add signed numbers. There's a whole chapter dealing with that in several courses ago if you took that course. Use your calculator. Negative 4 plus 2 is what? Negative 2. And so this is negative 2, right? Okay, now to graph a line, you just need 2 points, but sometimes you could make a mistake. So let's do another one. Let's do negative 5. So if x is negative 5, I get y equals negative 4/5 times x. And what's x? Negative 5 plus 2. All right, now, according to order of operations, see this is multiplication, this is addition. What do I do first? Multiplication. So I'm going to go off to the side. I'm going to say negative 4/5 times 5, negative 5, right? Over 1. Right? Reduce first. The whole point of multiplying by a number divisible by 5 is to get this denominator to be what number? 1. 1. 5 into 5 is 1. 5 into negative 5 is a negative 1. And now we multiply. I'm multiplying two fractions, right? This fraction, now that it's reduced, is what number? Negative 4. This fraction that's reduced is now what number? What's a negative 4 times a negative 1? Positive 4. So that is just this, right? But I got to do what to it? Add 2, and what do I get? 6. All right, so then we plot those 3 points. So let's go ahead and plot those. All right, now on that worksheet, make sure if it says label, and it does, that you label the points on your graph. All right, so I'm going to plot 0, 2 first. So 0, 2 is here, right here. Now labeling just means to indicate it as an ordered pair. 5, negative 2 is right here. So that's in quadrant 4. 5, negative 2. And then negative 5, 6 is in the second quadrant. So that's here. And then just use your ruler and draw your line. So remember, those 3 points have to be collinear. Remember, from a geometry course in the past, collinear means that the points lie in the same line. That's all that means. Don't forget, though, what some of you forget to do is this. So you do this, and then you get a little upset with me because you're going to get your full points. So why won't you get your full points if this is what you do? The arrows. Don't forget the arrows. Okay, so that was number 1. So this was y equals negative 4/5 x plus 2. It does. Her question is, does it matter what value you use for x? No, it doesn't matter because it would still lie in the same line. Yeah. So it better be falling, and it better lie on all of these. Whatever point you choose better be on this line. But I'm hoping you choose a number divisible by 5. Okay. Yes.
Whenever we label the point, do you want us to label on the grid, or do you want us to do it on the side?
No, on the grid like this, that's what labeling is. Yeah. So don't put it on the side. Yeah. Labeling means right next to the point that you just drew, tell me what that point is. Okay, now let's go to this one. So in the problems that we did, what value or what letter was already by itself? Y. That's always the easy kind is when y is by itself. But it's not always going to be the case. So let's get this one. 2x plus 3y is equal to, let's say, negative 6. 2x plus 3y equals negative 6. All right, so that was a little bit more complicated to deal with, just the way it looks. See, in the problems we just had, y was by itself, so it made things a little bit easier for us. So what you want to do is get the term that has y by itself first. So you see on the left side there, how many terms? 2, good. 2x and a 3y. So let's keep the 3y on the left side and bring the 2x to the other side. So just like we've been doing when you solve the equations, are you going to add 2x or subtract 2x? Subtract 2x. So I'm going to subtract 2x from both sides, just like this, and then we combine like terms. Okay? On the left side, I can combine like terms because 2x and a negative 2x is 0. So what's left on the left side? 3y. On the right side, are there any terms that are alike? No. But let's go ahead and put the variable first. So how are you going to write this? Negative 2x minus 6. All right. Now, before we go on, let me remind you about something. So this is a reminder. So as a reminder is, let's suppose I had 8 plus 6, and I'm dividing this by 2. Okay? Now, obviously, 8 plus 6 is what number? 14, and 14 divided by 2 is 7. But the reminder is this. In my numerator, you see how many terms? 2. And in the denominator, you see how many terms? 1. I can also rewrite this as 8 divided by 2 plus what? 6 divided by 2. And so 8 divided by 2 is 4. 6 divided by 2 is 3, which gives me 7. So that's going to be important when we do this one. All right. Now, just like when you solved the equations, those two worksheets you turned in, how do you get the variable y by itself? Huh? Divide by 3, because right now this says 3 times y, right? The opposite of multiplying by 3 is to divide by 3. All right, so I'm going to go ahead and rewrite this. Nothing different than what you turned in today. Just like this, what you do to one side, you do to the other. All right. Now, what's 3 divided by 3? 1. 1 times y is y. So now I have y by itself, which is what I wanted. Now let's look at the right side and make it look a little bit better. What's the first term you see in the numerator? Negative 2x. It has to be divided by what? 3. What is the second term you see? Negative 6. It has to be divided by what? 3. So that's where we're at. Okay? Now, let's simplify this a little bit better. You all agree that y is going to equal negative 2/3 x minus 2? Because negative 6 divided by 3 is a what? It's negative 2. So now that looks like the problem we just did, number 1. So on your worksheet number 4, I think it looked like 3y or something. You just divide both sides by that coefficient, and then you make it look better. Okay? All right, so let's go ahead and let's do the rest of this, number 2. Okay, so you want to graph this. So the graph of this equation is going to be same as the graph of this equation, right? Let's use a t-table. Those are directions. Use a t-table. You've had enough practice with the rest of this that this part should not be the issue. The issue should have been, well, this looks pretty bad. How do I graph this? Well, you get y by itself, so now you know how to do this. The rest you've had enough practice with. What are you going to use for x? 0. All right, x is 0. And again, if you need to, write it out. I get y equals negative 2/3 times x. What's x? 0. And then what? Minus 2. Well, we all know that any number times 0 is 0. And what's 0 minus 2? Negative 2. So that's one of my points. Yes?
Isn't y like the same thing as f of x? And some, I see in some parts.
We haven't done that yet. Okay?
And are we gonna do like, all of divisible by 3, right?
Yeah.
When you set up like 2x plus 3y equals negative, you just basically trying to get into y intercept.
You're trying to get y by itself. So one of the things you learned in the past was the idea of slope-intercept form. But they're not wanting you to use that, so I've never used that term. Okay? All right, but yes, it is the idea of that slope-intercept form. So when you get y by itself, you may remember from last semester, if you took last semester's course, that when you get y by itself, that's slope-intercept form. And you graph these equations using the idea of slope-intercept, but that's not what the idea is here. We want you to use this using a t-table. And the reason we use a t-table is because in a little while, you're going to be graphing something that doesn't look like an equation. I'm sorry, like a linear equation. So you got to use a t-table for that. So that's the whole purpose of doing the t-table here. All right, now choose numbers that are divisible by what? 3. So give me a number divisible by 3. Make it easy. 3. What's the next one? Negative 3. So let's just use those two. Okay, so if x is 3, I get y equals negative 2/3 times 3, right? Minus 2. So if you look at what I just wrote, I have a multiplication and I have a subtraction. What should I do first? Multiplication. So let's go off to the side. I'm going to have to do this on another sheet. Let's go off to the side and we're going to rewrite. Now some of you may need to do that. Rewrite that multiplication. Rewrite that product. And you may also want to rewrite that 3 that I have here as 3 divided by 1. So if you need to do that, you do that. Now the whole purpose of multiplying by number divisible by 3 was so that this denominator becomes a 1. So let's reduce. 3 into 3 is 1. 3 into 3 is 1. And so this fraction, when I reduced, is now what fraction that I'm pointing to? And this is 1. So a negative 2 times 1 is negative 2. Now keep in mind that that negative 2 represents just this right here, right? But what else must I do to this? Subtract 2. If you're having problems with signed numbers, use your calculator. What's a negative 2 and a negative 2? Negative 4. All right, so then I do one more just to make sure they all lie in the same line. So if x is negative 3, let's see what we get. So I'm going to get y equals negative 2/3 times negative 3 minus 2, right? So the variable x is just plugged in negative 3. And so I'm going to go ahead and just do the product. So here's my product, negative 2/3 times negative 3 divided by 1. Okay, let's reduce. 3 to 3 is 1. 3 to negative 3 is? Negative 1. Now let's multiply the fractions. This fraction is now what number? Negative 2. This fraction is now what number? What's a negative 2 times a negative 1? Positive 2. So this right here, this product, I just found that to be what value? 2. But what's 2 minus 2? 0. Okay. Now, let's plot those 3 points. Let's plot those 3 points. So 0, negative 2. 0, negative 2 is right here. Okay. Then the other one was 3, negative 4. Right here. And then the other one is negative 3, 0. So where's negative 3, 0 located? On the x-axis. Which side of the x-axis? The left, the negative, right? So y'all agree that negative 3, 0 is on the x-axis? So whenever it lies on an axis, it's not in a plane. Remember, this point that I'm pointing to, I didn't mean a plane, I mean a quadrant. This point that I'm pointing to is in a quadrant. What quadrant is this point located? 4. This point that I'm pointing to is not in a quadrant. It's on an axis. So it's on the y-axis. This is on the x-axis. All right. So do y'all see that those 3 points do lie on the same line? All right, just go ahead and use your ruler now. And don't forget to draw your arrows. And that's what we get. All right. All right, so that's number 2. So and that problem was 2x plus 3y equal negative 6. All right, now I'm going to make it a little bit harder. So let's do number 3. We're going to do one more, and then we're going to look at another way of graphing these linear equations. All right, so this is going to be a little bit harder to deal with. So let's suppose I had 2x minus 5y equal, let's say, 10. So 2x minus 5y equal 10. So the best way to do this, if they tell you to use a t-table, the way you want to do this, first of all, is to get y by itself. Okay? It's not by itself. So what should I do first if you look at this? Subtract 2x. All right, so a good thing. Subtract 2x. Combine like terms. What's left on the left? Negative 5y equal, and then tell me what to write. Negative 2x plus 10. Good. All right, so that's where we're at. Okay? Now, how do I get y by itself? Not subtract 5. Not add 5 either. Divide. Now you see how y'all said different things? You got to remind yourself, oh Lord, I messed this thing up. Let me see why and not do this on a test, right? Yeah. You want to make these mistakes on a worksheet, not on a test. So you got to remember, just like if you had an equation, if I said solve this equation, 2x equal 5, you didn't subtract 2, you didn't add 2. What did you do? You divided both sides by 2, right? Same idea here. You're trying to get y by itself. Well, when you read this, you read it as negative 5 times y. So I use the word times, multiplication. So what's the opposite of multiplication? Division. I'm going to go ahead and rewrite this over, though. Divide both sides by negative 5, just like this. And so negative 5 divided by negative 5 is 1. 1 times y is y. And just remember what we did a while ago. Let's write this as two fractions. So you're going to say negative 2x divided by what? Nope. Negative 5. Be careful. Plus 10 divided by what? Negative 5. So that's where I'm at. Okay? But now let's kind of make these two fractions a little bit better looking. A negative divided by negative is a positive. You need to do that. So y equals 2/5 x, right? So negative 2x divided by negative 5 is the same thing as saying 2/5 x. How do you think you may want to write the other one? Minus 2, because a positive divided by negative is a negative. All right, so that's where I'm at. All right, so notice as we went through the process, a couple of things that some of you were saying that could have given you a wrong equation. All right, so let's go ahead and graph this. Give me a value for x. Give me another value for x. 5, good. Give me another value for x. Negative 5. All right. So numbers divisible by 5. Okay, if x is 0, I get y equal 2/5 times what? 0 minus 2. Now that, when x is 0, that's an easy one, because 2/5 times 0 is 0. What's 0 minus 2? Negative 2. If x is 5, I get y equals 2/5 times x. What's x? 5 minus 2, right? All right, let's go off to the side and do that product if you need to. You don't have to, but if you do make a mistake, you need to start doing that. 2/5 times 5 over 1. That's what this is right here. Reduce. 5 and 5 is 1. 5 and 5 is 1. So I get 2 times what? 1 is 2. So this product is 2. 2 minus 2 is 0. Let's do negative 5. Y equals 2/5, sorry, 2/5, that's 2/5 times negative 5 minus 2. Go off to the side and figure out what this is. 2/5 times a negative 5 over 1. 5 and 5 is 1. 5 and negative 5 is negative 1. This fraction I'm pointing to is what fraction? 2. This is negative 1. 2 times negative 1 is negative 2. So this becomes a negative 2 and a negative 2, which is negative 4. Okay? And so you plot those 3 points. So 0, negative 2, 0, negative 2 is here. 5, 0 is on the positive x-axis. That's here. And then negative 5, negative 5, negative 4 is in the third quadrant. That's here. Yes.
What is a negative fraction?
What a negative fraction?
So, when you move the 2 over to the right side, isn't it negative y equals negative
Wait, I
2
don't know.
x minus
I
2?
can't. Wait, I'm sorry.
I have it as, I don't know how I got it, but I have y equals negative 2/5 x minus 2.
Where are you getting the 5 from? We're looking at, oh, I'm looking at the wrong one. I'm sorry. Y equals negative 2/5?
Yes.
But a negative divided by, when I divide it by negative 5, a negative divided by negative is a positive, so it becomes a positive 2/5 now.
Okay.
Okay?
I thought like you just make that into a negative fraction then.
Make what into a negative fraction?
Make that negative 2 -5 is whenever you have 2, it just becomes a negative fraction.
You got to remember, a negative divided by negative is a positive. A negative divided by positive is a negative.
Even if we keep it as a fraction.
Yeah, because okay, I'm going to ask you this. What's a negative 8 divided by 2?
-4.
-4. All right, so you're saying if you keep it as a fraction, okay? What is a negative 8 divided by 6 reduced?
That would be
-4
-4/3.
over 3. Okay, what's a negative 8 divided by -6 reduced?
-4, -3.
-4, -3. Okay, good. But what's a negative divided by negative? Positive.
But you can't divide it.
What do you mean you can't divide it?
You can't divide -4 by -3. So just
Yeah, you-
keep it as a fraction.
You just make
I'm not sure what you're talking about. You can't
If
divide.
you keep it as a fraction, you're not actually turning it into a decimal. Wouldn't you just keep it as a negative?
No. Okay, so a negative divided by negative is a positive. Okay?
Okay.
Even if you want to change it to a mixed number, it's still a positive mixed number. Your problem is that you're still having some sign issues with multiplication division. A negative divided by negative is a positive. A negative divided by positive is a negative. So you see, as I went through this, you still want to make this negative. You got to remember, a negative divided by negative is not a negative, it's a positive. Okay? Yeah, so,
Because my line is correct, but it's just in the opposite direction.
well, your line's not correct.
Well, yeah, but I mean.
It's the wrong line.
In line, yeah.
So you're saying they're collinear, but it's not the right line. Okay, so yeah, you would get any points. You'd lose all your points. Okay? So notice where your misconceptions are. You still seem to think that a negative divided by negative has to be a negative. Okay? So, all right. Okay. So that was did I finish graphing this? No? Okay. So the only thing I've got to do is to draw the line, right? So that's number 3, and that was 2x minus 5y equal 10. Okay? All right. Now,